Okay. Okay. So today we'll be starting with a new topic. This is part of
Logarithms.
some of your syllabus. It is not part of some of your syllabus, but this is a very important topic. Very important till 12th. This is very important for students from 9th to 12th class. Unfortunately, this is somehow it is not part of CBSE syllabus. I don't know why, but it is a very important topic. So, one second. Okay. So let us start with the basic understanding of logarithms. Okay. Now there is some prerequisites which you have to know for this topic. Do you understand the word prerequisite? Anyone knows what prerequisite means?
No, sir.
Prerequisite means this is a word means requisite. Requisite means something which is required. Pre means which is required before. Okay. So prerequisite means something which you require before doing something. Like a prerequisite for writing is having a pen. You get it, no? So the
It's basics.
prerequisite for understanding this topic is you should have knowledge of another topic called as exponents. Exponents.
Sir, indices.
Yeah, exponents, indices, whatever you call it. Base, power, all that you have to know. So does everyone is everyone comfortable with that topic?
Yes, sir.
Yes, sir.
So then,
Yes, sir.
okay, fine. So then this topic will be easier to understand. So we are going to start with the definition. If 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 A is any positive number, if A is any positive number, if A is any positive number except 1, comma n is any rational number.
Hmm. These are the side.
N is any rational number, okay? And A power n is equal to B. Then n is called, then n is called the logarithm. Then n is called the logarithm of b to the base a. Okay. Further is denoted. It is denoted by log b to the base a. So b you have to write above and a should be written below. Okay. So this is denoted by this symbol, and it is this is read as follows. Yeah, this symbol has to be read like this. So when you read this symbol, you have to read it as log b to the base a or logarithm b to the base a. Okay. For example,
Sir,
yeah,
this was a part of the ancient calculators.
yeah, this is part of the calculation. For example, if I say 3 square is equal to 9, okay. Now can you correlate it with this form and try to tell me what is the logarithmic form?
So can I say?
Yes, sir, can I say?
Sir, can I say?
Sir, can I say?
I'll say it for now, and then so here this is taking the this is playing the role of A, and this is playing the role of B,
B,
and this is playing the role of N.
N.
So from here this implies we can say that N is equal to log 9 to the base 3. Sorry, instead of N you can directly write
2.
2.
so from here we can tell 2 is equal to log 9 base 3. In other words, very important. In other words, if someone tells C equal to log A base B, this implies you can say A is equal to B to the power C.
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 So this is a fundamental understanding behind logarithm. Okay? Now let us see a few more examples. Yeah. Log 625 to the base 5. Can you try to tell what is this value?
No, not 3.
Sir, 4, 4.
4, 4, 4.
So 4.
4, 4.
Answer is 4.
Good, good, fine. So what is understanding? 5 power 4. 5 power 4 is equal to 625.
Yes, sir.
Okay. I hope everyone knows that 5 power 4 is 625. How do you know that? Because 5 power 4 can be written as 5 square whole square. And 5
Yes.
square is nothing but 25. So 25 whole square is 625. Okay. So if 5 power 4 is equal to 625, then can I say that log 625 to the base 5 is 4? Right? So after this fundamental understanding, now let us go ahead. Okay. Important. 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 Important ones. First and foremost, in log a to the base b, both a and b are always positive. Okay. I.e. where A greater than 0 and B greater than 0. So in log A base B, both A and B are always positive. Okay. Having said that, I am also saying, but the value of log A base B can be negative. Very interesting. So this note is telling, if you're telling log A base B, then A has to be positive and B has to be positive. But log A base B too can be negative. Okay. Let us see a small example. See, what is 2 to the power minus 2?
Sir, 1/4.
4. 1/4.
Okay. Now, if I want to write this in a logarithmic form, what can I say? Can I say minus 2 is equal to
Log
Log 1/4 base 2.
base 2.
Okay. So in this example, you can see how 1/4 is positive, so there is no problem. 2 is positive, but you see when you're finding the logarithm, log 1/4 to the base 2 turns out to be minus 2. Okay, is the example clear? Fine.
Yes, sir.
Now,
Yes, sir.
yeah, next point. The value of B does not equal to 1. The value of B is never equal to 1. Okay. Now there is a reason behind this. What is the reason? The reason is 1 power k, where k belongs to real number. Okay. For any
It is
real,
always 1.
yeah, for any real number k, 1 power k is always equal to 1. Okay. Now if you take log on both sides, k becomes log 1 base 1. See, what is the problem? This is not a fixed value now.
It's a variable.
Yeah, it is not a fixed value because this is true for all real values. So therefore, in general, whenever the base is 1, it does not make any sense to define the logarithm. Why? Because 1 power k is anyway 1. See, the point of logarithm is to find the exponent. You should understand this carefully. Logarithm is a topic we're using to find exponent. For example, if I say 2 power x is equal to 4 and I want to find x, that implies x is equal to log 4 base 2. That is what logarithms are used for. They're used for finding the exponent. So this is the main utility of logarithms. Okay. Now, if you want to find the exponent, now in this case, it does not make any sense not to find k, because k is, it is true for any value of k. 1 power k is always 1, isn't it? So in such a case, we generally do not use logarithm. Okay. So the value of base, by b I mean in this case b. Okay. I'm not talking about the alphabet b, I'm talking about the base. The base of logarithm can never be equal to 1. Okay, very important. Having said that, but if a equal to 1 and b does not equal to 1, this implies log a to the base b is equal to 0. Okay. See, what is the understanding? If a is equal to 1, then this is some log of 1 to the base b. Okay. See, we want to find the exponent of b. We want to find b power x such that this is equal to 1. For any real number b, positive real number b. See,
Anything to the power 0 is equal to 1.
yeah, yeah.
1.
Yes. See, any positive number to the power x should give you 1. When is it possible? It is only possible if
X equals 0.
x equal to 0. Why at any other point it will give you some other real value, na? Let us say b is equal to, I'll give you an example. Let us say b equal to 2. Then 2 power 1 is equal to 2. 2
2.
power 3 is equal to 8.
8.
2 power half is equal to
Root 2. Root 2.
2 power minus 1 by 4 is equal to
Fourth root under 2.
fourth root of
2.
1 by 2.
So 1 by 4th root 2.
1 by 2, sir.
Because it's minus sign given.
2 power minus 4 is equal to.
1 by 16.
1 by 16.
See, this is called a continuous function.
1 by 6.
Okay, wait. See, 2 power x is a continuous function. What is continuous function? We'll study in future class. In 11th class, you'll be taught what is continuous function. But I'll tell you in a very simple way to understand this. It means, see, at some point, when the exponent, when 2 power x, when x is negative, 2 power x is lesser than 1, okay? And when 2 power x, where x is positive, 2 power x is,
Greater than 0. X is greater than 0.
it is definitely greater than 0, but it is greater than 1.
Yes, sir, it is greater.
Yeah, so that means at the point 2 power x at x equal to 0, 2 power x is equal to 1. Because it is a continuous function. See, before it was lesser than 1. You see, whenever the exponent is negative, you're able to see it is a fraction less than 1. It is less than 1. And whenever the fraction is greater than 0, even over here, we are able to see that it is greater than 1. So when x is equal to 0, logically speaking, it has to be equal to 1. Anyway, this is an important property which all of you must have learned. A power 0 is always equal to 1, where a does not equal to 0. Okay? Is this clear?
Yes, sir.
So if a power 0 is always equal to 1, if I take logarithm, then can I say 0 equal to log 1 to the base a for any a?
Base A.
Yes, sir.
Okay. So this is the third point. Okay. Okay. So this was point number 3. Next. Point number 4. If log x base a is equal to log y base a, this implies x equal to 1.
X equal to 8.
Okay. What is the proof? Proof is let log x base a is equal to log y base a equal to some n. Let us say it is some n. So from here, what is the value of x? If I want the value of x, I have to equate only this part.
Sir, x equals to a to the power n.
A to the power. Clear, no? So from here, can I say x is equal to a power n? And simply, what is the value of y? Use this.
Y is equals to a to the power n.
Y is also equal to,
A.
which implies x is equal to 1.
Yes.
Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. I'll give a small question, you guys try.
Okay, sir.
Find the value of log 1728 to the base 2 root. Find the value of 1728 to the base 2 root 3. There is some specialty to this number. I told you the last class. Okay. So take that as a hint and try to solve this question.
Sir, answer is 9.
Answer is
9.
9. Huh? You said 9?
Sir, let me check. Sir, no, sir. Answer is 6. Answer is 6.
Yes, sir. Answer is 6. It's double of 3. It's double of
6 is the right answer. So solution. What is the solution? Log of 1728 to the base 2 root 3. Let us say it is some n. This implies 1728 is equal to 2 root 3.
Root 3 to the power n.
But what is
1728.
Sir, 12 to the
1
power 3.
12 to the power 3.
Yeah, good. We should remember these things. Seriously. Now, similarly, 2 root 3, if you take 2 inside the root, can I write it as 2 square into 3? Everyone knows this
Yes, sir.
property.
Yes, sir.
2 is equal to under root 4, no?
Yes, sir.
So that
Yes,
is
sir.
what I used here, right? So 2 square into 3. What is 2 square into 3?
Sir,
Sir, 12.
Root
12.
under
Root
12.
12.
So this,
Root 12. Yes, sir.
this is root 12 power. Now, can I write root 12 as 12 power half?
Yes, sir. 12
Yes,
to the
sir.
power 1 by 2.
N by 2 equals to 3.
Yes.
Yeah. So bases are equal. Therefore, power should also be equal.
N by 2 is equal to 3. Then that is 6.
6. Yes, sir.
Okay. Okay. Next question.
So can you go back to the previous screen for few minutes? For 1 minute only.
What's the reason? It's the last one. You get to participate on that.
Okay. So the next question is, given log x to the base 10 is equal to 2a and log y to the base 10 is equal to b by 2. Okay. I have a series of questions. First question, write 10 power a in terms of x. Second question, write 10 power 2b plus 1 in terms of y. And third question, if log p to the base 10 is equal to 3a minus 2b, express p in terms express p in terms of x. Take 2 minutes and try these three questions.
Sir, I am done.
Oh, good. Tell me, Swapnamit. So let Swapnamit tell. I don't want the others to interfere. Okay. Yes. Continue, Swapnamit.
Sir, question number one, it states that from the question states that log base 10 x is equal to 2a, log base 10 y is equal to b by 2. So according to first question, write 10 to the power a is in terms of x. So from the logarithmic expression, we can say to an exponential expression that 10 to the power 2a is equal to x. So 10 to the power a to the power 2 is equal to x, then root x is equal to 10 to the power a.
Is everyone understanding? This step is clear to everyone?
Yes, sir.
Rizwan.
Sir, then A equals to 1 to the power 1 into 1 half.
Does someone have some doubt? Any doubts? Is everyone clear? Ashmita, Narit, Hia, Pawan, Ronak, Rajiv, Yashwant, Anushita, Pratyush,
Yes.
Deepa, Sujita. No one has doubt now?
Yes.
Oh, sir.
Can you explain the? Can you explain this
Which one? Which step?
second step?
See,
This step.
Yes, sir.
This is definition. Na? If log x base 10 is equal to 2a, that means x is equal to 10 power 2a. Na? That is the definition. Na? If log a base b is equal to c, can I say a is equal to b power c? That is the definition of logarithm.
Yes, sir.
Clear?
Yes, sir.
Anyone else has any doubt?
Sir,
Yes.
sir, can we say that 10 to the power of A is equals to x by 2?
No, x power 1 by 2. Na? X to the power 1 by 2. How will you get x by 2? See, x is equal to 10 power a whole square. Just like, let us say, uh, 4 is equal to 2 square. Or this is maybe convenient. 9 is equal to 3 square. Do you agree? Okay.
Yes, sir.
So from here, we can say root 9 is equal to 3. But we cannot say 9 by 2 is equal to 3. Na? Okay.
Okay, sir.
Anyone else has any doubts? Clear? Everyone is clear? Okay then. Swapnamit, yes. Tell me the second one.
sir, second one, the logarithmic expression is log base 10 y is equal to b by 2. So we can write it in a way that 10 to the power b by 2 is equal to y.
Okay. Next.
And by both side, in the both side we give an exponent of 4, y to the power 4. No, sir, y to the power 4
Acha, acha.
is equal to 10 to the power is equal to 10
To
to the
10 to the
power
power 2b.
b by 2 into 4, which is equal to
Wait. Let me taking power. Taking power
4.
on both sides. Okay. And here we took square root. Here we took square root on both sides. Okay. From here, y power 4 is equal to 10 to the power 2.
10 to the power 2b.
Then,
Now we can say that 10 to the power 2b, 10 by 4 is equal to 10 to the power 2b
how?
into that
Multiplying?
same,
Yeah. Multiplying 10.
multiplying 10 on both sides.
Okay. Next step. Here bases are same.
Next step,
10 power 1 and 10 power 2b. And if bases are same, then
addition of the powers.
Addition of the powers. So 10 to the power 2b plus 1.
2b plus
10 to the 2b plus 1.
1. So therefore, this is the answer. Answer is 10 power 2b plus 1 is equal to 10 to the power 4y. This is the answer. First answer is root x. Second answer is 10 to the power
4y.
4.
No, 10y to the power 4.
Sorry, 10y to the power. Okay. Everyone is clear? Anyone has any doubt? Okay. Can we go ahead? Third question. If log p base 10 is equal to 3a minus 2b, express p in terms of x and y. Interesting. He's telling log p base 10 is 3a minus 2b, then find p in terms of xy. What to do? Somebody?
Sir, can I say? Can I
You're,
say?
you're blowing a concept like it. Oh, yes, go ahead. Log p to the base 10 is equal to. Just tell your auspicious answer.
Sir, from the logarithmic equations which were given with the which were given in the questions, we can say that 10 to the power 3 log log x base 10. From here we can say that 10 to the power 3a minus 2b is equal to p.
Wait. What are you using? You are using this expression, na?
I am using the
Okay, you tell me, I'll write down whatever you say. Tell me. Yes, go on.
sir. Sir, wait a minute. Wait a minute, sir.
Okay.
Sir, we know that 10 to the power
Yeah.
10
This.
to the power 2a is equal to x.
Hmm. Okay. So you're telling. Now this is your solution. You're telling.
10 so let us first write it as 10 to the power 2 is x, and then we know that 10 to the power b by 2 is equal to y.
Okay. 10 power b by 2, right?
Yes, sir.
Next.
Sir, sir, I did a wrong I did a mistake, sir. Can you, I will not be able to say the answer. Let me correct the question and then I'll say
Pratyush,
the
I think you
answer.
have some solution. Pratyush. Pratyush ji.
10
Pratyush, you have some answer? Oh. Pratyush disappeared. Okay. So maybe I'll do this question. So
Sir, can I try once again?
you keep trying. I'll write whatever I have. You want to tell something?
Yes, sir. I'll give the solution of the sum.
Okay, go ahead. Tell me.
Sir, the logarithmic expression states that log base 10 x is equal to 2a.
Okay.
From that, we can derive the value of a as half log base 10 x. A is equal to half log base 10 x.
Okay.
From the second equation, we get that log base 10 y is equal to b by 2.
Okay. Next.
Yes, sir. Then from here we get the values of a and b. So from the equation, from the logarithmic equation given in question number 3, we get that log 10 to no sorry 10 to the power 3 minus 3a minus 2b is equal to p.
Okay. So you are telling it is given that p equal to 3a minus 2b. Okay. This is equal to. Now I have to
Yes,
substitute.
sir. Yes, sir. Sir, it is 10 to the power 10 to the power 3a minus 2b.
10 to the
P is
power.
equal, sir, P is equal
Oh.
to 10 to the power.
Yes, sir. P is equals to 10 to the power 3a minus 2.
Yeah, good. So if log t base 10 is equal to 3a minus 2, this implies p equal to 10 to the power 3a minus 2. Okay, well and good. So this is all in the
Then
expression.
we substitution of value b which is equal to 5 to the power. Then
Something like this. No?
yes, sir.
Okay, next.
Then we multiply it 3 by 2 log 10 to the power 3 by 2 log x. P is equal to
10 to
10
the
to the
power.
3 by 2 10 to the power 3 by 2 log x.
Okay, 3 by 2 log x. And
And that's there minus 2 log minus 2 log y.
okay, minus 2. And
Then the next step will be 10 to p is equal to 10 to the power log root x to the power 3.
okay. How did you tell that it is root x power 3?
Sir, because according to the power law, when something to the power product is there,
Mhm.
something to, that comes that is multiplied with the logarithmic equation.
Yeah, I did not teach na yet. Power law.
Sir, we can also write this at x root x.
Uh-huh.
Sir, root x to the power 3 can be also written as x root x.
Root x to the power 3 can also be written as x root x. Yeah, true. So how will that help here?
Sir, is it correct?
Yeah, this is correct, but how will it help here?
Sir, uh, can
Ah,
you please write what I told that 10 to the power
10 to the power.
log root x to the power 3.
See, we'll get the answer, but I wanted without using the property because I did not teach. Na. You're telling this only,
Sir,
no?
I have a doubt.
Yeah. How did I
Sir,
write
then
this?
we can divide it.
So the question is P is equals to 10 to the power 3a minus 2b.
Okay.
Therefore, over here you have directly written 2 log y to the base 10. It should be 2 into 2 log y to the base 10.
Yes, correct. We made a mistake. Thank you.
Yes, sir, that's only the problem. I also got 4 there.
Yeah. So there should be
4, and that should be then y to the power 4.
then this will be y to the power. So from here you're telling
Now,
this
sir, we can write
log
yeah 10 to the power log x to the power 3 by 2 by y to the power 4. Now by this will simply be equal to, yeah, that's again a law.
yeah, but see, we did not discuss all these laws. No?
Now we can just write it in the terms of x and y.
Yeah, but it's not good. See, how will the other students understand? Because we did not discuss all these laws. So can anyone try to do this question without using these laws?
Sir, I found it easy. That's why I did with the
Okay,
laws.
I agree, it is easy, but it's not taught yet. So I cannot expect people to know now
Yes.
without teaching. You might know, but can we do the question without laws? Okay. So I'll show you one way. I'll try one way. Okay. So in this question, it is told that p is equal to 10 power 3a minus 2b, and we want to find things in terms of x and y. Can I say this is nothing but, do you know the law of exponents that 10 power 3a minus 2b can be written as 10 power 3a divided by,
By 10 to the power 2b. By 10 to the power 2b.
Yes, sir.
yeah. But then we just found in the first part that 10 to the power 2a is nothing but x. So here we have
Yes,
10
sir.
to the power 3a. So can I write this as 10 power 2a whole power 3 by 2? See, 2a into 3 by 2. What is 2a into 3 by 2?
Sir,
3A.
3.
So instead of 3a, I am writing 2a into 3 by 2. Is this okay? Is everyone okay with it?
Yes, sir.
Okay, good. Next, now the denominator is 10 power 2b. Now, can you guys think what to do with 10 power 2b? We found that y is equal to 10.
Yes, sir. B by 2 into 4. B
Yeah.
by 2 into 4.
So I'll write this as 10 power b by 2 whole power 4. Is that okay? Everyone is fine with it?
Yes,
Fine.
sir.
Yes.
But from first question, we already found that 10 power 2 is nothing but x. We found that here. 10 power 2 is x. And y power 4 is 10 power 2b. Yeah, so we know the value of 10 power 2b and 10 power 2a. So can I say this will become x power 3 by 2 divided by y power. Is this okay?
Yes, sir.
Yes, sir.
Better.
Does anyone have any doubt?
No, sir.
Clear?
Yes, sir.
So can you explain the denominator, how the denominator changed? Can
Okay. Let us do one thing. Even if we, let us say I don't change the denominator, I'm keeping it as 10 power 2b. But over here, sorry. Oh, yeah. Remember this part of the question? Log y base 10 is equal to b by 2. Y is equal to 10 power b by 2. So y by 4 is equal to 10 power 2b. We derived this here in the last part. Okay, Anushita.
yes, sir.
So instead of 10 power 2b, can I substitute y power 4?
Okay, sir.
Is that okay?
Yes, sir.
That's what I did. Instead of 10 power 2b, I'm substituting y power. Is it understood?
Yes, sir.
Okay. Is anyone having any difficulty in understanding things? Please let me know. Okay. Next.
Sir, we did not complete the answer.
Oh,
Oh, no, no.
the question is to
No,
explain.
it's done, sir. It's done.
Yeah, it is to express it in terms of x and y. Na?
Sir, done.
Yeah.
Right.
I
Sir,
thought
in terms of
individually. Individually x and individual y.
No. X and y combined. Okay. Fine.
Yes, sir.
Next heading. Standard. Okay. Standard property. First one. Log m into n. Log m into n to the base a. Or rather, you write it this way. Log m base a plus log n base a is equal to log m into n base a.
Sir,
Yes. Any problem? Any problem?
sir,
Can you tell?
I can't see. I can't.
Your voice is not clear, Nair. You want to say?
Write in the chat box.
Uh-huh.
Sir, I'm telling him to write it in the chat box.
Yeah. Okay. Okay. So this is the first law called product law. If you have log m and you add into log n base a, then the base is, if the base is same, then this is called as the argument. Okay. This part is generally called as the argument. If you have log a base b, I'm saying that generally this part is called as the base and this part is called as the argument. Okay. Just remember this.
Sir, Nareth is saying that he's not being able to see the screen.
We are not able to see the screen. Others?
Sir, I can see.
Yes, sir, we can see it.
Okay. Okay. I think
Sir,
that,
maybe he has some connectivity issues.
yeah. Narendra, you can just reconnect yourself. So I'll write the properties first and then we'll come back to the proof. Okay, is that okay? Is that okay?
Yes, sir.
Or should I do the proof right now?
Sir, you can do the
Huh?
sir, you can do the proofs.
Okay. What is the proof? Proof is let x log m to the base a is equal to x and let log n to the base a is equal to y. Okay. That implies m is equal to, what is the value of m? Can anyone tell me? Or wait. I'll
A
ask.
to the
I'll ask,
power x.
and whoever I ask, they should answer, right? Ronak, can you tell me what is m? Ronak Mandal. Ronak, can you tell me what is m?
Sir, can I prove it, sir?
No. I'm asking.
Sir, no, sir.
Oh, very basic thing. No? Okay, next. Rajiv Sharma, can you tell me what is m? If log m to the base a is equal to x, what is m? Rajiv Sharma. Rajiv Sharma, am I audible? Uh-huh. Ashwant?
Can I say? So can I say?
No, wait. I just want to see if everyone is understanding. See, because if someone is not understanding, you can let me know. I can explain. Ashwant, can you answer? If log m base a is equal to x, then m is equal to what? What is the value of m? Yashwant? Hmm. Okay, who else? Adrika, Adrika, can you answer?
Yes, sir.
Adrika Mandal.
A to the power x.
A to the power x, yeah, thank you, very good. And similarly, n will be?
A to the power y.
Very good.
A to the power y.
No, A, na? Where did B come from? This is also A. Okay. Now,
We can multiply these two values.
multiplying these two equations. Okay. If
This
A, what
mn
is,
equals to
yeah, A power
ax into ay.
yeah, what is A power x into A power y? If bases are equal, then
So we can
E to the power
add
x,
the
A to the power y x plus y.
that means Mn is equal to, hence, Mn is equal to A power x plus y. Okay. Okay. Now again I'm going to ask. I'll ask. Yeah. Rajesh Sharma, can you answer? If m into n is equal to a power x plus y, can you tell me in the form of logarithm how can I write this? Mn is equal to a power x plus y. How do I write this in terms of logarithm? Did you understand question? Rajesh Sharma, did you understand question?
Yes, sir.
Okay. So can you try to answer? M into n is equal to a power x plus y. That means how do I write this expression in terms of a logarithm? Not. Can you tell or you want to pass? Rajiv,
Sir,
you can answer?
sir, sir.
Huh? So what is the answer? Okay, take your time. Hiya Sarkar, can you tell me answer? Yes, no? Hiya Sarkar, can you try? Okay. See, this is in something is equal to some base to the power something. What is that something? M into n is equal to a to the power x plus y. Now my question is how to put this in form of a logarithm. This is like a power b is equal to c. Remember?
Can I say?
can I
Wait, I'll ask. I want everyone to answer. Ashwant, can you answer? Ashwant. Okay, yes. Who can answer?
Sir, I.
Okay, tell me, Ashmita.
Sir, can I?
Sir, it will be log mn to the base a equals to x plus y.
Yeah, good. X plus y will be equal to log mn to the base. Okay. But what is x and what is y? We defined x now over here. We ourselves defined x and y. Okay. So instead of x, can I write this? So from here,
Yes.
can I say log m to the base a? This is the value of x, remember? And similarly, the value of y is log n to the base a. So by replacing x and y with the original equations, okay, we are getting log m to the base a and log n to the base a. When they are added, note that if the bases are same, you can add them, and the arguments are getting multiplied. See, this is like the inverse of what you learned in exponents. If the bases are equal and you're multiplying two terms, then the powers are added. But here, if the bases are same and you're adding the two logarithms, then the arguments are multiplied. Okay. In fact, exponents and logarithms in your higher classes, we'll discuss in your higher classes in 11th, 12th class, you learn that both of them are called inverse functions. One function is the inverse of the other. Okay. Yeah, Swapnamit, you want to say something? Okay. So this is the first property along with the proof. Okay. Now, corollary. Corollary. Does anyone know what you mean by corollary?
No, sir.
See, corollary means suppose you have any theorem. Anyone wants to try? What do you mean by corollary? Okay. Corollary means suppose you proved a theorem, and from that theorem you're able to say you're able to prove some other theorem. Then such a consequential theorem is known as corollary. Okay. Okay. Uh,
Sir,
yes.
so normally corollary means something which is already proven or it's proved.
Okay. Corollary of a theorem means something which is like a byproduct of the original theorem. Okay. For example, here the corollary will be log m to the base a plus log n to the base a plus log p to the base a will be equal to log m into n into p to the base. And like that, if you have n terms, all of them will be multiplied. Let us say you have log a1 base a plus log a2 base a, and you have log a3 base a, so on till log an base a. So on adding all of this, you get log of a1 into a2 into so on till an to the. Okay. So this is known as the corollary. Okay. So generally many theorems have corollary theorems also. Fine. Is this clear?
Yes, sir.
Now we're going to the second property. Second property is log of m to the base a minus log of n to the base a is equal to log of m by n to the base a. Please unmute me. All of you are unmuted only. I did not mute anyone. Okay. So can
Thank you,
anyone?
sir.
Yeah, can anyone try to prove this? Who wants to prove? Sir, again you mute. See, I'm not muting anyone. I don't know why this is.
Sir, can you explain that corollary one again?
What the word means? See, it's simple. Corollary
Yes,
means
sir, the process you did.
how we got this.
Yeah.
Okay, see.
No, not this, the whole step that you did up to last one.
Yeah. See, can I take these two and add them? In addition, this is allowed now. You can add first. Let us add these two things, and after that, we'll add this. So if I add these two first, what will I get? I get log mn to the base a plus log p to the base a. Again, I can use the same property. You're adding two logarithms.
Yes.
So we'll get log
Yeah.
m n p. Clear? You do the same process here also. Take two at a time and keep adding more and more. You'll get product ultimately. Okay. Clear?
Means in the last step you took log A as common, right?
Yeah, it is not common, but everything has everything is multiplied. In logarithm, if all the bases are same, then all the arguments are multiplied. Okay.
Okay. Yes, sir.
So now, what is the simplest way to prove this? The most simplest way to prove this is proof is log m by n to the base a can be written as log of m into n minus 1 to the base a. And by addition theorem, this is nothing but log m to the base a plus log of n minus 1 to the base a. Okay. Oh, we have to. Actually, this becomes minus log n base a. But since I did not explain it, let us not do it this way. We'll prove it in some other. Wait, just 1 second. Same. Let us do it in the same way. Let log m base a be x, and let log n base a be equal to y. Okay. Now, if you subtract both of these things, m is equal to a power x and n is equal to a power y. I'm sorry, if you divide both of these things, this implies m by n is equal to a power x minus 1. And now if you take logarithm on both sides, you get log of m by n to the base a equal to x minus y. But x minus y is nothing but log m to the base a minus log n to the base a. Okay. So this is the second law. Third law. Third law is very important. Log m to the power n to the base a is equal to n times of log m to the base a. Log m to the power n base a is equal to n times of log m base. Proof. Again the same thing. let log m to the base a equal to x, which implies m is equal to a power x. So if I take power n on both sides, can I say m power n is equal to a power x whole power n, which implies m power n is equal to a power n times of x. Okay. Now taking log on both sides. See, here I take power n on both sides. Take power n. See, sometimes even if I don't write this, I hope you people are able to understand. Take power n on both sides. Because generally you're supposed to write like this in exam. But in class, if I write this, then it takes a lot of time. So sometimes I might skip. In school, your teacher must be writing this step every time. But here, generally I tend to skip. But still, if someone wants me to explain, I'll explain any step. Okay. So it is important to ask. If you don't understand anything in class, always ask. Okay. Don't hesitate. Or else I'll assume that you understand, even though it might happen that you did not understand. Okay. So from here, we can say m power n is equal to a to the power n into x. Okay. Now I'm taking logarithm on both sides to the base a. Log mn to the base a will be equal to n times of x. But what is x? X, we already defined x over here. So this is nothing but n times of log m base a. Okay. Clear? Okay. Can we go ahead? Oh.
Exactly.
Okay. Where we did this. So this is the third law, right?
So can
Corollary.
you explain again the third?
Rajesh, have you asked something?
Sir, can you sir, can
Yes,
you
Rajesh.
explain again? Sir, sir, can you explain again the third law?
Yes, Raju, explain what?
Third law, sir.
Rajesh,
Yes,
what
sir.
which step you didn't understand?
Sir, 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 I didn't understand the proof.
Your voice is not clear. Okay, you can put it in the chat box. Whatever you didn't understand, type it in there. I am not able to unmute myself. Okay, I think there is some issue with internet and muting also. I did not put anyone in mute. So please. Okay. Okay. So there are more corollaries for this theorem also, and they're very important. Just like we had a corollary for the first theorem, we have a corollary for this theorem also. What is the corollary? Right. Corollary is a power log x to the base a is equal to x. This is very, very important. Very, very important.
A to the power log x base a.
Yes, a to the power log x base a is equal to x. Example, 2 to the power log 6 base 2 is equal to 6. Okay. What is the proof? So some of this is the second law. Okay. First law is addition, second law is subtraction. And in third law, we are seeing that log of m power n, if you have it in this form, then whatever is the exponent, it comes in front. It becomes n times of log m base a. And what is the proof? Proof is let the let this quantity be some x. So log m base a is equal to x. If log m base a is equal to x, then can I say m is equal to a power x? After that, take power n on both sides. Rajiv, you are understanding? Take power on both sides.
Yes,
This
sir.
step is clear.
Yes, sir.
This step is this step clear, Rajiv?
Yes, sir.
This step. Okay. This step is also clear. Okay. So therefore, the whole proof is clear to you. So I am going back to the proof now. Okay. So the proof of this is let log 6 base 2 is equal to x. If log 6 base 2 is equal to x, from here can I say that 6 is equal to 2 power x? This is the most basic definition. If log 6 base 2 is equal to x, then we can tell 6 is equal to 2 power x, right? But what is x? X is log 6 base 2. X itself is log 6 base 2. Na? So here in this equation, very important to understand, instead of x I am writing log 6 base 2. Hence proved. This is a very important property. So if you have, if the base in the exponent and the base in the logarithm are same, then the answer will be the argument. This is the property. Okay. This is the very, very important property. I hope everyone understood. Okay. On, you understood? You had some doubt?
Yes, sir.
Yes,
Sir, can you, sir,
Yeah, yeah.
sir, can you repeat the last statement which you said that if the base and what said I didn't remember.
Base of the exponent and base of the logarithm, if they are both same, then the answer will be the argument. We are calling this as argument. No, I just put.
Yes, sir.
If base of the power and base of the logarithm, both of them should be same, then answer is x. That is what the corollary is saying. Okay, fine.
Okay.
Can you
Sir, we can
One by one.
Can you
Yes,
sir,
yes.
can you explain the second law again?
Second law is exactly same as first law. First law, if you add, they are multiplied. Second law, if you subtract, they are divided. Okay. First law, when we added them, they multiplied na m into n. Second law is saying that if you subtract them, they are getting divided. Okay, here.
Okay, sir.
Okay. And proof is exactly same as first one. Right. Anyone has any more doubt here?
No, sir.
We are going ahead.
No.
So the next corollary, this which law is this? Maybe I'll give a better numbering. This is law 3, na? So let me
So
call,
please,
yeah, I'll call this 3.1, and then the corollary 3.2. Corollary 3.2 is telling log a to the base a is equal to x. Log of a power x to the base a is equal to x. Not very difficult to prove.
Sir, can I say the proof?
Actually, it is very. If you are strong in the basic concept of logarithms,
Or can I say it?
yeah. See, I think all of you can do the proof yourself. It's very easy, but just remember this, okay? I'm not going into the proof because we are short of time. Let us move on to the next property. Next property 4 is saying log m to the base a is equal to log of x to the base by log of m to the base b. Very important. You can express a particular logarithm having m as argument, a and a as a base in this form. You can write it as the division of two further logarithms. Of course, and here b should not be equal to 1. All the laws should be satisfied. Right? So what is the proof? What is the proof? Let log of m base b equal to k1, and let log, or k1 is might be little convenient to you, let us say x, and let log m to the base, sorry, log a to the base b equal to y.
Sir,
From
why?
here, y, yeah. From here, can I tell m is equal to b power x, and can I say a equal to b power y, right? From here, can I say m power 1 by x is equal to b, and a power 1 by y is equal to b? This is okay?
Yes, sir.
Okay. So you want division, right? Yes. So from here I am substituting. This implies a power 1 by y is equal to m power 1 by x. Or in other words, m is equal to a power x by y. This is clear. Can I say m is equal to a power x by y from this step? From here we can tell log m to the base a is equal to x by y. And not resubstituting the original values, you get this is log m base b by log A. Clear?
Yes, sir.
Yes, sir.
I'm going to write the corollaries, and you guys can try the corollaries at home as homework.
Sir, what? I did not hear
The
it, sir.
Can you
corollaries
please
I'm going to
repeat?
The
write.
what?
You try to prove them at home.
Okay,
Okay.
sir.
They're easy only, don't worry. Log n to the base b.
Okay, sir.
I think first some of you must have finished first one already.
Yes, sir.
Sir, it is our homework.
Yeah, it is very simple. You can try it at home.
Sir, in the first
All
two,
done.
a law is common.
Yes, sir.
The first one, if you just take this part to the other side, if you divide, then you get the previous law, isn't it?
Sir, we can use the reciprocal law too.
Yes, sir. For the second one. Sir, if we take log A by B as x, then log B by A will be 1 by x.
We can tell it also in the. We can use it in the first one too.
Yeah, yeah. Here
Yes, we can.
you can use a hint. Hint is log a to the base a. What is log a to the base a?
1.
Sir, 1.
This is the hint. Okay. And then if you prove second one, then third is also easy. Okay. Okay. So if there are no further doubts, then we can end the class here. And I have plenty of questions for all of you, which I will give.
Sir, for assignment.
Yeah. So anyone has any doubts from this class, feel very free to ask it. Because this is a very fundamental topic. If you have doubt, you can let me know. We can discuss it. Does anyone?
Sir, I have a doubt.
Yes.
Sir, can you please just define the corollary again? I just wanted to ask.
What corollary means? Huh?
Yes, miss. Yes, sir.
Okay. Maybe I'll
Yes,
show.
sir.
One second. I'll show you something on. Swapnabit is showing his body. Swapnabit, you're showing your biceps.
No, sir.
You're trying to
No.
threaten. Are you trying to threaten me? Okay, see, I typed it in Google. Corollary. A proposition that follows from. Again, you'll have doubt what proposition means. Proposition means to propose. Propose is a verb. Proposition is the act. Forming a proposition that follows from one already proved. Are you able to understand, Pawan?
Sir,
Okay.
your voice is a bit cracking.
Okay, but the screen is clear, no?
Yes, sir.
Then the corollary, here it is written on the right corner. In mathematics and logic, a corollary statement is a statement which can be readily deduced. You know what deduced means? Deduced means you can prove it, okay? It can be readily proved from a previous statement.
Oh, sir, like a postulate
No, no,
we use in congruency.
no. Postulates are
You can,
different.
sir, because if we use readily to them, if we readily use them, we can prove whether the triangles are congruent or not.
The postulates don't necessarily have proofs always, but corollary can be proved. Okay.
Oh, Sir, like this is a kind of it.
Like Dalton had a postulate. I think Dalton had some postulates that atom is indivisible.
Yes, sir.
But atom is divisible.
Yes,
It
sir.
can't be, because now we know that there is something called electron, proton, graviton, meson, boson, whatnot. So these are postulates. If you want, I'll type postulate. Postulates. See, postulate, first definition, suggest or assume the existence. You get it? Postulate means you're assuming something is true on based on some sort of belief, discussion, or reasoning. You understand it?
Oh, sir, but corollary is proved that it is the fact.
Yeah, corollary can be proved from an earlier proof. If you proved A, then from A, if you're able to prove B, then B is called corollary of A. Understand?
Sir, can you repeat again?
Corollary means, let us say, okay, wait. Let us say, very crude example. Let us say Pawan Sathik bet me. This is the statement. Corollary is he is very angry with me because he bet me. You can say he is very angry with me. Something like that. If you can prove something from A, but its importance is not as important as A. That is what the definition said. I will go back to corollary. You see on the right side of the page. In mathematics and logic, a corollary is a statement which can be readily deduced from a previous statement. Means first statement can be proved. Okay, statement from a previous statement, if you are able to prove one more statement, that is known as corollary. Okay.
Yes,
So
sir.
as
Thank
you
you, sir.
understand. Okay. Like, see, now also I made a statement. Statement was log m base a is equal to log m base b divided by log a base b. What is the corollary? Corollary is log a base b is equal to 1 by log b base a. Okay. Why? Because to prove that log a base b is equal to 1 by log b base a, we are using the original statement. है ना? To prove this, you are using the original statement. Therefore, this is known as a corollary of the original statement. Are you guys understanding little?
Yes, sir. Thank you, sir.
Okay, here there is an example. A corollary would be like this. If a triangle is equilateral, it is also equiangular. Understand? If it is equilateral, then all the angles are equal. That is an example for corollary. Fine?
Thank you, sir.
Okay.
Sir,
Any other doubts?
thank you, sir.
Okay, so I think we'll end the class here. Thank you very much. So keep waiting. Check your mails, WhatsApp group, whatever you have. I'll be sending assignment sometime. And maybe we'll have a test also sometime. But I'll let you know before we have the test. Okay. Thank you very much.
Okay, sir.
Thank you, sir.
Thank you.